Okay, we have a sun, we have Earth, and gravity. So technically, we have everything we need for a solar system. I'm just gonna put Earth right here and then press run. Oh, Earth just fell into the sun. That's slightly inconvenient. Okay, let's try the second time. This time, let's give it a lot more sideways speed. Oh, it has left our solar system. Fantastic. So apparently, there's a very thin line between destroying Earth and launching it into deep space. Let's find it. So far in Hold the Universe, we've played with particles, gravity, stars, galaxies, and even black holes. And somehow, we're still alive. Today, we're using those same ideas to build something closer to home, our own solar system. If you've been building this universe with me, tag, like, and subscribe. Think of it as funding the simulation with absolutely no money. Also, tell me in the comments which planet you want me to experiment with next. Alright, let's rescue Earth. Here is the weird part. To make Earth orbit the sun, we don't actually tell it to orbit. We let it fall. Gravity is constantly pulling Earth towards the sun, but Earth is also moving sideways. Moves too slowly, and gravity wins. And congratulations, you've invented a very expensive collision. Moves too fast, and Earth escapes. But somewhere between those two disasters is a sweet spot. Earth falls towards the sun, but because it's moving sideways, it keeps missing again and again and again. That endless fall is what we call orbit. And this is where gravity gets even more fascinating. There's a scene in the series Young Sheldon that I've always liked. His mom is struggling with her faith, and Sheldon tries to help her in the most Sheldon way possible, physics. He points out that if gravity were a little stronger, the universe could collapse. And if it were a little weaker, stars and planets wouldn't form the way they do. His point isn't that physics can settle the question of God, it can't. But the precision of the universe makes you stop for a second and wonder. However you interpret that, I love the thought behind it. The universe doesn't just look spectacular, it runs on rules, and today we are playing with one of those rules. Now let's turn that rule into code. First, the sun. We're giving it almost all the mass in our little system. So naturally, everything else is going to care a lot about where it is. Next, Earth. We give Earth a starting distance. And this time, instead of randomly getting it into space, a carefully chosen sideways velocity. Now comes the important part. Every frame, we calculate how strongly the sun pulls on Earth. That changes X velocity. Then the new velocity changes Earth's position. Gravity, velocity, position. Repeat that calculation thousands of times, and something beautiful should happen. Now, there's run everything and see what it looks like. Okay, 25% still alive. Alpha in orbit, 75%, come on, and yes, one complete orbit. Earth isn't burning. Earth isn't halfway to another star. We actually did it. Two objects, a few equations, and a lot of repeated calculation just gave us a working planetary system. But one planet, that's adorable. Let's build the rest. First up, Mercury, tiny first, and ridiculously close to the Sun, then Venus. It is already here, so next comes Mars. 4 rocky planets, not bad. But we need the big guys. Jupiter enters the simulation and immediately makes everybody else look tiny. Then Saturn, and yes, I gave it rings. There was absolutely no chance I was building Saturn without rings. Then Uranus, and finally Neptune. 8 planets, 8 different distances, and 8 different orbital speeds. And somehow, nobody has crashed into anybody. I'll take that as a win. Which of these planets should get its own episode? Drop your choice in the comments down below. Now, here's the part I've been waiting for. At normal speed, space is honestly a little too patient, so let's cheat. 10 times faster, 100 times faster, and 1000 times faster. Look at Mercury. That little planet is absolutely flying. Earth started burning through years. Meanwhile, Neptune is basically saying, I'll get there when I get there. And when we pull all the way back, there it is. 8 planets, 1 star. A system that has been moving for billions of years, recreated with code on a computer. We started this series with particles. Those particles become stars. Stars became galaxies. We bent space around the black hole, and now we have a solar system. But there is one object here I keep coming back to: Earth. Because an orbit alone doesn't make this place special. Temperature, atmosphere, liquid water, chemistry. Somehow, all those pieces came together here. So, next time, we're going to ask a much harder question. Can we use code to build a planet that could actually support life? That's episode 7. And I have a feeling this simulation is about to get a lot more complicated.